Okay, in this video, we are going to move on to Project 5. This is part 1 of Project 5. So I haven't written the write-up for Project 5. By the time this video gets out to your Google Classroom, it will be done. But Project 5 is the same as all your other projects. You're keeping track of a list of songs. I'm keeping track of a list of videos. Instead of an array of videos or an array of songs, you're going to have a linked list of videos or songs. And that's what we're going to see in this. A couple of new things other than that is we are going to see how to insert the songs or the movies in the alphabetical order. So to start with, here's the program that I've actually tested. It's not quite done. I've only done part 1. So again, this is going to be a little larger than Project 4. So we're going to do it in parts. We're going to do at least 3 parts to it. So part 1, if you look at my text file here, has a bunch of movies and they are not quite in alphabetical order. You have another A down here. If you notice, there's an A there. The F comes at the end. So when I load this, it will be loaded in alphabetical order. And then after that, every time you add, it should be done in alphabetical order. We are not going to call any sort functions. As we add, we are going to check and we're going to compare and we're going to insert in the right spot. So the first thing we would be adding would be Avengers because it's the first item in the list. There's nothing else there. You add that. Then you add Happy Feet, which should come after A. Then you add J, which comes after H. So those things are getting added. But then here, when you come to the another A, which is Aladdin, which has to go before Avengers, you're always going to start from the top of the list. Every time you add, you're going to start from the top of the list and see where does it go in the right position. So Happy Feet so happens that it comes after A. J, Jumanji, comes after H. But when you come to Aladdin, you start from the top again. You say, oh, A comes before Avengers. AL comes before AV. So then you're going to stop right there. You're going to insert before Avengers. Likewise, when you get to Frozen, Frozen is greater than A, but it's less than H. So the minute that you find that this is less than H, or if string 1 is less than string 2, then you stop and you insert in that spot. If string 1 is not less than, so your comparison would be to see if the new string that you're looking at is less than the string in the list, then you're going to stop. Okay, that's the kind of comparison we're going to use for this. And so that's our goal. So if I run this program for you using Valgrind, just to show you how the end result looks, and if I say D to display, notice how Aladdin is inserted. That's not how it was in my text file, but it's inserted in the right order. Okay, so let me go into my text file and move some things around. So I'm going to put Aladdin back somewhere at the end, just so we know that our program is working correctly. Then I'm going to move Jumanji all the way to the top. And I'm going to move Wonder Woman before that. And I will get rid of Aladdin from there. Okay, so now it's not in order. Let's change Wonder Woman 1, make it Wonder Woman 2 with a different year or something. Okay. All right. So now nothing is in order. It's all different. Now we can start looking at our code. So the code files that I have here, both sides are the same folders. I'm going to show you first video.h and video.cpp. Really nothing should change here. The only thing I added here was to show you how to do the operator overloading. And operator overloading, the assignment operator, means you don't have to do that deep copy every time. If you overload the assignment operator, meaning if you teach it how to do your copy, video copy, you can use the assignment operator to do that. It'll make life easier. So the prototype for this says we are returning a reference to a video. So add this. Operator equals, this is the syntax, you cannot change that. Some of these things are really set, there's nothing much to change. It takes a video object by reference, okay? And on the right hand side, if you look at the way it is actually done, here is the prototype. Here's a heading. You check to see if this a video object is the same as the object in scope. That means it's a self copy. It's like saying x equals x, right? Why would you do that? A video equals a video. If that is the case, then return the pointer. Don't do it. It's returning a pointer. It's returning a reference. That's what that is, okay? Else you're going to copy, you're going to essentially do the deep copy here, so that way you can use the assignment operator in your code. So you check your title, which is your char array. If you have two char arrays, you have to check both of them, delete the memory allocated to it, set it equal to null, allocate new memory just enough for a video's title, string copy from a video into, and you can, this is a string n copy. You can do a string n copy or a string copy, it doesn't matter, from a video's title to this title. And copy the year, which is what I'm doing. You need to copy all your appropriate data members. If you have song name and song artist, two char arrays and two ints, then you copy all of them appropriately and return star this, which is returning a pointer. So that will help you overload the assignment operator, and it will make life a little easier, okay? Okay, that's done. That's in video.h or in your single song.h and song.cpp. Now for the actual linked list. That has nothing to do with linked list. That was just to make life easy for you. Then you go to video list.h, and on this side you go to video list.cpp. Here's where the changes are. The first change that you need to make is to make sure you have the struct node as a private data member with your song, data, and node star next. Okay, I have a video data, you'll have a song data. That's all it is. Head pointer, tail pointer, and a count. The count helps us keep track of the number of nodes in the list. Head and tail to keep track of our head pointer to the list and the tail pointer to the list. That's it. Then I have a function here to be able to insert sorted. Notice is less than. Remember, you've been writing this function. This takes two char arrays. I compare the two char arrays, string 1 and string 2. If string 1 is less than string 2, it returns true. And we will use this to insert into our list by alphabetical order. On the right hand side, the things that need to be changed, starting from the constructor, a lot of things need to be changed. The constructor has to have head equals null, tail equals null, count equals 0. It's an empty list, default constructor. Constructor from file, head equals null, tail equals null, count equals 0. Nothing else changes. We read from the file. We populate a video. Again, nothing changes. A video is a temporary object, okay? Add video is where we actually implement all our changes. So let's go to add video. Here's my get size function, nothing changes, returns count, okay? My add video function is where most of the changes are, and that's what we are focused on in this part. Add is going to add, insert, sorted in our case, okay? So just like you did in your homework 2, you have a new node, which is the same as my temp node in the homework, current. I also have a previous, because in this case, we're going to see how to not only insert at the beginning or at the end, we're going to see how to insert in between. So we need previous and null to be able to help us insert in between. I have temporary string 1 and string 2. Remember, we have our is less than function. We are going to need that to try and figure out where to insert. So I have two char arrays. I have a temporary title char array. I have some temporary variables. Populate new node. You create a new node so I can attach it. So I'm going to switch to my whiteboard here. Here's how our original starter point is. Head equals null, tail equals null. Both of them are empty. New node equals new node says create. I'll call it NN for lack of space here. This is my video object. This is my pointer. So if you look in our code here, I've created new node equals new node, allocated memory for it. New node data equals a video, which is this here, a video. And this is my next pointer pointing to null, which is what we did. Now we got to start attaching it. First thing you see is check to see if list is empty. If not, head. If it is the first node, whether it's adding at end or adding at beginning, it doesn't matter. You simply say head equals new node, tail equals new node. Okay, so we have attached the first node. So it's going to look like this. I have attached the first node, head equals new node, tail equals new node. That's what we have done there. Okay, so I'm assuming, let's say we're going to use letters instead of movie names. It's easier to write for me. So whatever it is, the first one, maybe it started with an A, I put it in there. Okay, now we are reading from the file. The next one, let's say, is a node that starts with the letter C. Okay, so we go into that, we create, again, all of this is skipped for the first time, right? If not head, you attach the new node and we are done. We are not going to do any of these. Count gets incremented all the way at the bottom. We go back. Here we are adding the next node. We go back. The next video gets, the next video is read from the file. The add video gets called. We start over. We are adding the next node. Maybe it's something that's coming in with the letter C. So new node equals new node data. You do all of that stuff, meaning you go in here and you're going to say, okay, I'm going to create a new node. So let's create this new node. Maybe it has the letter C, something starting with the letter C. You put that in there. New node next is set to null. Now you're going to go check your if statement. If not head, head is already pointing to something. So it's not going to go into that if, it's going to come here. Else, current equals head. I'm going to have a pointer called current pointing to head, whatever head is pointing to. Then you're going to say current data dot get title of string 1, current data. Okay, so what we are doing is we are getting current data dot get title of string 1. So that means string 1 is going to have A. That's what we're doing. We're simply getting the title from that node. New node data dot get title. We are going to get new node, which is this. This is new node. Its title into string 2. That's what that's doing. We are essentially going to compare now to see who is less than who, so we can figure out where to insert this new node. Okay, new node data dot get title string 2. While current and is less than, while current says as long as current is pointing to something, and as long as is less than string 1 comma string 2 returns true. That means if string 1 is less than string 2, is string 1 less than string 2? Yes, A is less than C. So we are going to move current. What is this saying? As long as both of these conditions are true, which it is in this case, current is pointing to something, and A is less than C, we are going to say previous equals current. So now I have a previous pointer. Previous equals current. I'm going to make previous also point to whatever current is pointing to. Current equals current next. What is current next? Current next is pointing to null. So current is pointing to current next. So current, notice, is no longer pointing to this node. It's pointing to null. Current equals current next. Okay, here we are in our while. If current, is current pointing to anything? If current will be false because current is pointing to null. We will not do this if. We will not try to get the next title, otherwise it'll crash. So current is not pointing to anything. Current is pointing to null, so it will not do this. Go back to the while current is false because current is at null. We come out of the while. Check to see if we are at the end of our list. Now we know we have come out of the while. We need to insert somewhere. Now again, we have to check. If not current, current is pointing to null, not current is true. So we are inserting at the very end. Tail next equals new node. Tail equals new node. Okay, we have a tail. That tail is pointing to this. Tail next equals new node. So what we are doing is we are essentially taking this and pointing to this, which is what we really want, right? And we're going to get rid of. Okay, so tail next is pointing to new node. Tail equals new node. So tail has moved over here. So tail is not there anymore. Tail has moved over here. We've added C to the end of the list. Now we go back. None of these are true. So count gets incremented. We are done adding. We go back and read the next line from the file. Now I'm going to read something with a B, which is going to get inserted in between. Okay. So we go back, new node data. We're doing all of this stuff over again. So now here's some. So this is how our list looks now. Now we are going to insert in between. So new node is starting with the letter B. New node equals new node next equals null. We populate new node. That's what we do right here. Right here, new node equals new node data is a video that's starting with B, next equals null. If not head is not empty, head is pointing to something. So we don't go in there, we come here. Current equals head, current equals right here. Current equals head. Current data dot get title of string 1. So string 1 equals A. New node data dot get title of string 2. String 2 equals B. While current, that's what my code says. While current and is less than. So current is pointing to something. Is less than of A and B is true. Yes, A is less than B. So current equals current next. We move current over. Notice that's what we do. Current equals current next. Previous equals current. First you have to do previous equals current. Don't move your current next first. Previous equals current. So previous equals current. Then current equals current next. Order of the statements matter a lot. So we moved it. Then we go back. Then we check if current data dot get title of string 1. We need to get the next string to compare. So yes, current is pointing to something. It's not empty. So we get title. So string 1 now becomes C. Is C less than B? That's my next. We go back to the while and that's what we check. We get title from this into string 1. Then we go back and check while current and is less than. Current is still pointing to something, but is less than returns false because string 1, C is not less than B. So it returns false. When it returns false, we come out of the while loop. Now it's time to insert. And that is right because B has to go in between A and C, right? So it comes back false. So we stop moving and we're going to insert. Previous is here, current is here. Now we're going to insert in between. Again, we check for the special case. If not current, that's as if we are inserting at end. If not current is not true. Current is pointing to something. So we come here. Else if previous, this is another case. Previous, yes, previous is pointing to something. So we are in this else. New node next equals current. So here is new node next. New node next equals current and previous next equals new node. All we have to do is say new node next equals current. Make this point here where tail is pointing to, and new node next equals, or I'm sorry, previous next equals new node. And that's it. And this has been broken. And we have made this connection. So then now the list looks like this. Head is pointing to A is pointing to B is pointing to C, tail is still there, right? So now the last case, now you get the idea, the last case, if we are inserting something before A, what if you're doing something with AP versus AA, right? So then it is going to do the same thing. You create your new node, you check while current and is less than will return false right away because this is going, if this is greater than the one that you're trying to insert, we will stop right here. Then we are in this last case where you're inserting at the beginning. Then you simply say new node next equals current, head equals new node. So if you are inserting at the beginning, it's going to look like this. Here's my new node. Maybe it has something with an A that goes before that. There's no previous. Remember, previous is not there because this is the very first thing that we are doing. Previous never moved. Previous is set to null. Right here. Previous moves only if we are moving down the list. If we never move down the list, we are going to insert at head. Previous never moved. Previous is not there. Current is here though. Okay. So current is here. Previous never moved. So we have to be very careful. New node next equals current. New node next is this. You point it to where current is pointing to. Head equals new node. So then we've inserted at the beginning. When you say head equals new node, this gets broken. This is no longer pointing to that. So then our list looks like this. We are pointing from, I don't want this to point to this anymore. Okay, so now we are pointing from head to this, to this, to this, to this. Okay, so draw it out and check it out and see how it works. That is the only way to figure out linked lists. So this is important for your assessment. You must be able to insert sorted, meaning you check the string coming in with the string in the list, which is what we're doing here, and insert at the right position. The only other thing that I have in here is the destructor. The destructor is important to figure out how to delete everything in your list. Okay, now to the destructor. So let's say we have our list here and we want to get rid of everything in the list so we can deallocate all the memory. So you make current point to head. Okay, if you look in my code, that's what I say. Current equals head. While current, that means as long as current is pointing to something, head equals current next. Move head to the next one. Head equals current next. Move head over here. Delete current. That means this memory gets deallocated. Current equals head. So current now moves over here. Okay? Get rid. So current is not here. Current has moved over. Then in your loop, delete head. This gets deleted. That's not right. What do we have? Current equals head, while head equals current next. Move head first. Don't delete it. Move head to the next one, then delete it. Then move current. Move head to the next one, which is now null, then delete current. Move current. Current is at null, so our loop stops. So see what we're doing is if you delete this when both head and current are pointing to the same thing, then we break this link and there's no way to access the rest of the list. So make sure both of them start pointing to the same thing. Then you move head to the next one, then delete current, then move current, then move head to the next one, delete current, move current. That's what we're doing. So one has to be always ahead of the other. Okay, so those are the only two pieces of code that is in here that I've written. Everything else has been removed. So if you look in my search, I said to be done. Write data, I've written because that's just going through a for loop and printing it. Remove, I have not done. My print simply goes through a for loop like you did before, but with a current pointer. Node star current, you can say for current equals head, current not equal to null. That's the same as saying current. Current equals current next. Cout, I output count, which is just a counter, and current data dot print video. Remember, again, we have our print video, which will print itself. You call print video using current data. And write data is exactly the same thing, but I call print video with out file. So these two are easy functions. They just go through and print the list. Okay, and then of course the is less than function. So these are the functions that you need to implement. Mainly the add, the is less than, the destructor, and the print. I don't expect it to do anything else for part one. So try this for part one. Be able to insert, sort it,